assembly language. Can you see that how they written assembly language? Move edx length, and then move some other variable, and then message. This is how assembly language look like. Okay, so if they were subtracting any two numbers, they have to write a sub subtract variable 1 from variable 2. So that is how assembly codes look like. Okay, then this is the small diagram that will explain how the compilation process goes on. So the first stage is pre-process, and then pre-processing phase, where we know it removes the commands, all the command, and then it import that modules. And the compiler has two phase. First one is analysis phase, which means the front end phase, and then back end phase, and next move on to assembler. A loader in between, there is a loader, then linker. When the linker phase, that all the compilation will be over, and then you will get the .exe file, right? So the .exe file, you can take that code and then you can run anywhere. So ma'am, you may ask how we can run exe file. See, for example, I'm a programmer. I developed a billing system, so that that particular exe I can install into any other shops. See, after that, if, for example, if you go to grocery shop, there is a computer, right? They are not compiling all the time, right? So they use the exe, and then they open that tool, so the billing tool, whatever. So after compilation process over, then when exe is generated, then compiler is not necessary. You can take that exe file and then you can run anywhere. So that is what they are mentioning. Okay, you got it now? Then let's move on to interpreter process. Okay, before that, we will see some of the difference between the compiler and then interpreter. So the compiler takes the entire program, as I told you before, as an input. The interpreter takes a single instruction as an input. So then what it will take? It take the first instruction and then convert into machine level. Then it sends it to execution process. But intermediate object code is generated. No intermediate object code is generated here. The conditional control statement are executes faster in compiler, but here little bit slower interpreter, because it runs one by one. An interpreter converts one by one. So here compiler, it converts the entire thing in a one go. So the loops are, it will run very faster. So Python is a interpreter language. Python, and then Perl, and then PHP. So these are all the C++, C#. These are all programming languages, called programming languages. So C and then C++, C#, and then those languages are based on compiled. So I would call compiled language. Okay, so these are all the differences. Then we can study a little bit about interpretation process. I don't want to say it again and again. The interpreter, what it will do, it will take the first instruction and then convert into binary. I don't have any, what is that? Okay, I can write it here. This is code 1. Interpreter converts into binary. For example, this, how many bit or byte, it depends on the instruction size. So this is code 2, and then in between there is a interpreter. It will convert this way, 1 1 1 1 1. Then if I pass n number of codes, and then it will line by line it converts, and then only one interpreter is there in between. But if it is a compiler, it converts everything all together. You can put some boxes here in your textbook. They explain that in a diagram, so you can easily understand. So next, move on to operating system. role of operating system. So you have learned that once a program is turned into executable form, they can they can run anywhere. I told you, right? So after that, our operating system has a major role to play the execution of that program. Okay, those days, I yesterday I told you that those days I can run only one program. So for one program means any one of the two. When I open that computer, if I want to do some coding, I either COBOL or program C or Fortran, Basic. These are all called programming languages. I can only work with only one of them. So now I can able to do multitasking, right? Here I can do PyCharm, even though I can call shell. I do. See, this is also there's some editor here. See, A equal to assigning some of the list. If I press enter, it will return. So simultaneously, I can run that PyCharm as well. So different kind of EXEs, I can run it at a time, right? So the operating system manages the major role. See how the process means it running a program. So if I run this program, this is first process. I would say I'm running here. Now I'm working on a PyCharm. So this is a one process. Now the operating system give the first priority to the PyCharm. So I'm writing something here, and then right away I'm moving to Word doc. Then it will the PyCharm process will go for wait state. Then the operating system allot the memory for here, because I'm updating here something. So if I update something here, then this is the active process. So let's see how the operating system allocates the memory, and then how the process resource managers work. We will see now. Okay, the program when it is not running is simply lying on the disk. When it is executed, it must be loaded into that memory first. Now in this the operating system Microsoft Windows. So it will give the memory for this word process. Whatever I do here or I save here, if I use a cloud computing, okay, little bit I'll explain. So the cloud computing, you don't need to save anything here. It will, but only thing you need an internet. If you have an internet and then fixed all the documents and then Google drive everything, it will save for you. That is a difference between normal computing and then cloud computing. Okay, so in this chapter, this year you are not going to read cloud computing, because the portions are deleted, reduced a little bit, right? So that is why. Okay, next move on to the moment of the resource manager. When the program is loaded for running or execution, that is called process. Okay, then multiple programs are interrelated with each other. So when you run too many things, I am moving here. Okay, I am showing. Okay, let's run here. By the time I'm going here, see here now. Okay, let me write a simple program you can understand. A equal to input of enter name. Then B equal to input of enter your roll number. Print A comma B. Okay. Okay, this is my program, first program. When I run this program, it may wait for, to enter here. Can you see on the bottom? This is console panel. Whatever the result, the error, it will display in this window. Okay, then I resize that window. So it will display here. So which means this process is on a waiting state because it is waiting for the user to enter that value. That's how I wrote code here. Okay, before entering it, I'm just moving here and there. So the operating system has to manage all the resources, process efficiently. So otherwise, we don't like that working style, then we will go for another operating system, right? So that is why operating system plays a major role of communicate, interconnect with software and then hardware. Okay, so it provides some of the functions. The operating system provides some of the functions which are called process management, process scheduling, memory management, IO management. Let's see one by one. Okay, before that, I will show the diagram. New means one process is loaded into the memory. So when it is ready, for example, here when I work here, so the new process is ready. Okay, something is writing and then it has to save or whatever. Then when I started to run that code, I just see the diagram. When I see schedule dispatch. Okay, if I click here, one second. Okay, now new process means I'm ready to run this code. My cursor is on the PyCharm editor, so which means this is the active process. Okay, so when it is ready, the schedule is dispatched. Okay, the memory is allocated, you can run. So when I run, sometimes it may goes to waiting state. See, any reason, see the IO request, the input request is here. Sorry guys. So can you see that diagram? So when it is running, IO request, which means input output request. So I'm running, I have to pass that data, the corresponding data for A, but I'm doing something. I'm talking with you and then showing this diagram. Now my cursor is on that Windows, Word. So I'm adding something and then I want to save this. Immediately it goes to wait process. So sometimes it may block, or this process will be suspended because I may while explaining I'm adding something. Okay, the process schedule, whatever, if I do that, then I'm saving it, which means that process will be suspended or terminated, or still it is the waiting mode. Maybe by accidentally I close that PyCharm, that cause the process is suspended, right? Maybe power failure, anything happens, right? So, okay, for time being, I'm not suspending that PyCharm. So I'm working here. I don't mind about that one. So I'm going to work on that shell. This is also, the Python editor. You can use a different way. Next chapter, you will learn how PyCharm and then shell will work, and the Jupyter notepad. And there is a notepad called Jupyter. You can run that Python codes, small piece of code. You will see how it will work. So completely I ignored this time the PyCharm. So I'm started working on A equal to 5, and then B equal to 6. I'm going to add a C equal to A plus B. So what will happen? Completely that process is in a waiting state. So which process? The PyCharm process, right? That will be in a waiting state. Then I'm assigning some other new process. For a new process means what, where I am working. Maybe here I'm entering something and then saving. That is a new process. Okay, after typing something, I'm moving here. Okay, I'm gonna enter value for this. John, TOH and John. Again, it is waiting. So by the time I'm moving, this is how this, the process management will work. Okay. So maybe I don't like this. Maybe I'm given some irrelevant data. It may terminate it. So what will happen? That process will be suspended. Then it will allocate the operating system fetch that second process. What is the second process? I may work here, so it will fetch this process in an active state. Okay, so this is the small diagram. You have to understand how it works. Then when it comes to active process, there are different states. So what are all those? You can see that starting initial state of process. So what is the initial state of process? When I move my cursor again and then I'm doing something, okay, this process is initiated and then it is, the memory is allocated. The active process is a initial state of that process. Okay, next one is ready stated, and the process is ready after wait. See, put hold for some time, few minutes, right? So to run this code, right? So that is the now it will become a ready state. Okay, then I'm running this code. Then running state, the process is executing by the CPU. When I run this code or when I work on this, okay, now the PyCharm process, I'm giving name, but operating system give different code or something for each process. Now it is a running state. This process being executed by CPU. Okay, waiting state means it may wait for the resources. So that's what I told you before. It is waiting here for the resources means any data you have to enter. Okay, imagine another example. In the grocery shop, they can play with anything, right? So when they open that billing thing, they can enter scan one item and then it will display that they have to calculate total. So otherwise, the customer may ask many questions. They that billing, that page is on a waiting state. So waiting for that data. When the cashier click total add, some button will be there. When it is clicking add button, then only it calculate all the money, the corresponding items value, then it will display the total, right? So when terminating state means after cashing out, they take that cash from the customer and then reduce that balance and everything done, that process is completed. Okay, here when you come to the PyCharm, okay, one second, I'm giving 12 and then 23. What will happen? I'm not doing anything. I just display that A and B. So this process, when this process is over, then I can move into something else. Maybe I can create a new thing and then new project, whatever. So this first process is over. This is how the process management allocates memory, and then it has some other states, the initial state and then whatever. Okay, then let's move on to how CPU executes the instruction in a ready process. So okay, once the first process, I'm again telling you the process means it is a running program. And, the executing entity is called the process. So what is a running program? Right now we are running what, the MS Word, right? So when this program is loaded into main memory, the control unit brings first, once, okay, imagine this. So I'm working on that. So Now the operating system knows the running processes on the Python program. Okay, so now and what I'm going to do here, I'm going to add something, c equal to a plus b, then print c. Okay, when this process is loaded, then control unit checks, okay, whether any arithmetic logical operations are there or not. If arithmetic or any logical operation will be there, then control unit determines, okay, you perform arithmetic units, logical unit, do this work, and then it will obviously this arithmetic logical unit produce some result, right? So then control unit allows that memory for that variable. So when we assign first thing, when we run that code, so okay, data 12 is entered for that variable object. Python, everything we call as a object. You will see later chapters. Okay, so memory is allocated for this, and then when I press enter, then one more variable. So I'm entering something. Immediately, what it will do, the control unit, the CPU allocates that memory for that. Okay, so 2 digit of memory or 2 byte of memory. If it is a floating point, it will allocate a certain memory. For example, COBOL or Fortran, if I assign integer value, it allocates 8 bit of memory. So if I assign string value, maybe 32 bit of memory will be allocated. So the Python, it is a cool language. So how many bits you are assigning, that much memory only allocated. Here we pass 2 digit data, so 2 bit will be allocated. Then when compiler moves to third state, okay, then control unit takes place. Okay, there is arithmetic logical operators. Okay, that will perform their job. Then ALU produce result, right? So a plus b equal to something else. So when when I press here enter, see there is a result, and why there is 1223. Okay, I will dig in out of what is going on. I will tell you later. Okay, and so the resultant value, okay, when it is displayed after calculation, then CPU allocates memory for that variable c. So this is how it works. For the next instruction, maybe I'm calculating or something. If I move here, then what will happen? Immediately the operating system fetch that second process, and then it will run that these two. Okay, so suppose my program 100 lines of code means after calculating this two, then again it will the next process maybe I will select this program to run, then this process will be repeated. The program is loaded into main memory, the control unit brings the first instruction to the program, and then if there is any operations are there, then control unit takes place, and then it will produce the result. This is the way it will work. Then let's move on to the process scheduled by OS. So so what is a process scheduled by OS? Yeah, we are moving, we are changing here. Google.com, I'm assigning what is the time in the US. Come on. What is time in US? See, I told you process is the running program, right? So, the multiple programs we are running simultaneously, the computer has to understand, the operating system has to understand, okay, which one comes first, and then which process will, get a CPU time, and then how much, time allotted for each process, and then which one process has moved from CPU, and then which process has to shifted to IO. Everything that operating system has to manage, right? So, in case any interruption happens, I explained that in that diagram. So, you just imagine this one, the operating system schedule that timing and okay, let's move on to first schedule. Which process will get the CPU time? So the first, there is a strategy, first come first serve, which means when you are in a line queue, standing on a queue, then who will get first and then who will come out first? The first person who is standing on the queue, they will get information, or whatever the data, then they will come out first, right? So there are different strategies. So the round robin method, then shortest job next. So which process first? First strategy we will see, that is first come first out. In this strategy, you can always imagine first come first serve means queue. Queue is the example for first come first serve. Okay, for example, I'm running this program. Maybe imagine this is 500 lines of code I'm running simultaneously. I'm running this piece of code, a equal to plus a whatever, hello world. Already I have written hello world. Simultaneously I am running this. So what will happen? So the operating system arrange that other processor, which processor goes first. Okay, this is the shortest one, right? So it will go first, and then the memory is allocated, because my program, this program is a big one. But if I click first this one, it will take first place, right? Then whatever it is, the second come after, after clicking this, then I'm working on that. So which means the first processor is a python program, then it will move on to the second one. Okay, after finishing this, the same story repeats. After completed this code, then this process will be removed from the CPU. Okay, done. This is done. So this process, the python program process, will be removed from the CPU. Okay, imagine we are running a big program. So which process has to shifted to? I told you the same thing will repeat here. Round robin method. Okay, the first come first serve, that, right? So which process goes first, that will the CPU will allot the memory, and then it will be executed. Then round robin method means even every process given some fixed amount of time on CPU, that is time slice. For example, if I ask to run here and there, I'm just forget about python, anything. I'm using many I open many tabs here. So only I'm working on these tabs. Imagine this, which means the process CPU allot a fixed amount of time. So it may be in a millisecond or whatever. Here now I assigned what is the time in US, and then I can message here. Okay, if the process is over during the time, the process will be terminated. So in many things, maybe I'm running this pycharm, and then same thing here. When it is over, that will be terminated. Then otherwise this state is changed to waiting state. Okay, and the same story, but whatever we have learned before, start state, ready state here. The starting state, the waiting state, the same thing. Even though the round robin method also, it will distribute the same amount of time. The CPU allot the same amount of time, and then it asks to run that. Maybe first process is finished, then it will terminated, and then it will fetch into the second process. Then how? Okay, CPU asks. Okay, imagine here. I'm importing 2-3 modules. See, the Python main program, this .py is called modules. So here I'm asking you to run, I'm writing code that fetching these module, these module, everything put together here, and then I'm running here, which means 3-4 modules will be run simultaneously. Okay, this module I have written big, 10 15 numbers of code. Then this module I have written only 1 2 3 4 lines of code. So imagine you have running different process. When the main program is running, in this main program I'm calling different modules, so that module will be stored here or anywhere, somewhere here. Maybe I can store in that library, or anywhere I can store it. I can import that module, and then I'm asking you to asking to run that program. So what happens, the different modules will be running simultaneously. So this module is a shortest module, it will be run fast, and then that goes termination mode. Then how the CPU fetch the data, it maybe by the time I can assign what is the time. This is a very shortest processing time, right? So it will fetch allocate memory for this. Okay, this is what we are studying here, terminating state. What, guys, you all following me, or I'm just talking in the air? Guys, you understand?
Yes,
Yes,
ma'am.
ma'am.
Okay, sounds good. Okay, then memory management and then virtual management. One second, hold on, guys. I haven't taken notes. Okay, guys, I'm winding up now because I haven't copied anything here to explain. Tomorrow we will see the memory management and the virtual management and the IO management. Only 3 topics are there, and then we will finish this chapter. Okay, guys, you all fine, right?
Yes,
Yes,
ma'am.
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 Oh, okay, guys. Okay, I'll call off now. We will see tomorrow.
Thank you,
Ma'am,
ma'am.
Thank you. Bye.
Thank you.
ma'am,
Uh, yeah, Sanjay.
ma'am, I need to take screenshot of the first topics, ma'am. First few topics.
Uh, this one,
Yes, ma'am. Starting, ma'am.
starting this one. Oh, okay. Okay, everything is on the textbook, but I have taken something special. Okay, I'll send it through WhatsApp. Okay.
Okay, ma'am. Thank you,
Okay.
ma'am.
Okay. Bye.
Thank
Bye.
you.
Yeah.
And
Bye.
for me also, ma'am.
Huh? You needed that?
For me also.
Yeah. Yeah. I will. Send it in a group. Once I finish
Okay.
this chapter, I will send it. Okay.
Okay,
Thank
ma'am.
you.
Bye.